Hello, welcome to homework 31. Today's objective, I can write expressions using negative exponents, and I can evaluate numerical expressions containing negative exponents, all right? In class today, we established what it meant to be a negative exponent. We established what it means when you have a number raised to the power of 0 and when we have negative exponents. So I wrote some algebraic rules here, and we'll go through them real quick. So let's talk about this first one here. So it says for a not equal to 0, meaning for any number except for 0. When any number is raised to the power of 0, our answer is 1. 0 raised to the power of 0 is the only exception, only one that is not going to be 1. Okay? But any number raised to the power of 0 is going to be 1. Any number except for 0. And my example here, same one we did in class. Oh, let me fix that. 5 to the power of 0 is equal to 1. All right. The other rule we have down here, I know it's a bunch of letters and stuff like that. For a not equal to 0, when any number a is raised to a negative exponent, so negative n, it'll be equal to 1 over a to whatever that positive exponent is. Okay. So for example, 5 to the negative second power is equal to 1 over 5 to the second power. But we saw that today, and it's the same thing as me saying 1 over 25. Okay, so those are all equivalent to each other. Okay, so all that's happening here is we are taking the reciprocal. Okay, we're kind of flipping the value here. All right, so let's get into seeing if we can make some equivalent expressions. So we want to write each expression using a positive exponent. So 2 to the negative third power. So let's say if we could write 2 to the negative third power using a positive exponent. Okay, so negative exponents simply, as we said, mean we're going to take the reciprocal of it. So the reciprocal of 2 is 1/2. So all this is going to turn into is 1 over 2 to the positive third power. So 2 to the negative third power is the same thing as 1 over 2 to the positive third power. All right. Same rule applies here. M to the negative fourth power. Well, the reciprocal of m is 1 over m to the fourth power. All right, let me extend my bar here. There you go. So 1 over m to the fourth power is the same thing as m to the negative fourth power. All right. Again, negative exponents just means we're going to take the reciprocal of. C, we're going to write each fraction as an exponent using a negative exponent other than 1. Write each fraction as an expression, using a negative exponent other than negative 1. Okay? Well, 1 over 4 to the second power, similar to the ideas that we just saw. 1 over 4 to the second power can simply be rewritten as 4 to the negative second power. Think about it. If I take 4 to the negative second power, I would ask myself, what's the reciprocal of 4? And it would be 1/4. So just like we just did, we're almost doing the opposite of what we just saw. Okay, so 4 to the negative second power. All right, 1 over 27. So we want to write this with a negative exponent that is not 1. So let's think, what expression involving exponents can I get equal to 27? Well, I can rewrite that as 1 over 3 to the third power. And what's 1 over 3 to the third power? Written using a negative exponent now, it would be equal to 3 to the negative third power. All right, last one, or last two. Evaluate each expression if m is equal to 4 and n is equal to 3. Okay, so same as always, we're just going to substitute. All right, notice we have a negative n here. So if I substitute, I'm going to have negative 3 to the negative third power. All right, negative 3 to the negative third power. Well, I asked myself, what is 3 to the third power? So let's see if we can, oh, sorry, I didn't change my slide. Sorry about that. Negative n to the negative third power is going to be equal to negative 3 to the negative third power. So let's see if I could rewrite that here. So that's going to be the same as a negative 1 over 3 to the third power. And because we have that negative here, that means we're going to be doing negative 3 times negative 1/3 times negative 1/3. So let me write that out, what this means. So this means negative 1/3 times negative 1/3 times negative 1/3, which is going to be equal to negative 1/27. The only reason that it is negative is because our original expression had that negative end there. And because a negative times a negative times a negative is a negative. Okay? Last one. Let's substitute. So we will have 6 times m, which is 4, times n, which is 3, to the negative third power. And we actually just figured what 3 to the negative third power was. All right, so 3 to the negative third power is 1/27th. So we could say 6 times 4 times 1/27th, which is going to be equal to 6 times 4 is 24, times 1/27th is 24/27. I believe we do have, we can simplify this. I think we can divide top and bottom by 3. So divide by 3. Oh, where's my division? Here we go. 3 divide by 3. All right, and that would give us 8 8/9. All right, and that is it. All right, watch that order of operations, watch your multiplication. Negative exponents don't always just make our values negative. It takes the reciprocal of. All right, check out those practice problems, and I'll see y'all tomorrow.